Imagine a universe stretched beyond comprehension, where the last star has flickered out and galaxies have long since dissolved into a cosmic mist of isolated particles. This is not the fiery chaos of a big crunch, nor the tearing abyss of a big rip, but a silence so profound, so utterly devoid of energy, that motion itself is a forgotten concept. Stand at the edge of this infinite frozen expanse. Here, entropy has peaked, and the cosmic engine has run its course, leaving behind a cold, featureless void stretching into an eternity of nothingness. Yet, in this ultimate desolation, a flicker, a lone thought, a fleeting sensation, a fragment of perception igniting in the boundless cold dark, this ephemeral spark, a Boltzmann brain, is a bizarre quantum anomaly, a self-aware entity spontaneously assembled from the vacuum, complete with vivid memories and a full understanding of a universe that, by all accounts, no longer exists. Could your entire experience, the intricate narrative of your life, the very laws of physics you believe govern reality, be nothing more than such a final, random echo? Today, we journey into the chilling depths of this scientific paradox. We will explore the universe's most likely ultimate demise, uncover the bizarre theory of Boltzmann brains, examine the unnerving probabilities that suggest they might be more common than true observers, and confront the unsettling possibility that our experienced reality is nothing but a final, vanishing memory in a dying void. If this journey into the profound mysteries of existence resonates with you, please like this video and subscribe to Terran for more explorations into the cosmos. Prepare yourselves, we begin. Our journey into the profound takes us first to an unsettling destination, the universe's ultimate inescapable fate. For centuries, humanity has pondered how it all ends, envisioning cataclysmic crashes or fiery restarts. Yet, the consensus among cosmologists points to a far more serene, yet infinitely more desolate conclusion: the heat death of the universe. This is not an explosion or a dramatic collapse, but a slow, inexorable fading into an eternity of cold, dark, and utterly featureless uniformity. It is the triumph of entropy, the relentless march towards maximum disorder, a cosmic clock meticulously unwinding until nothing remains to tick. To truly grasp this cosmic denouement, we must first understand the ironclad decree of the second law of thermodynamics. This fundamental principle dictates that in any isolated system, entropy, a measure of disorder or randomness, can only increase or remain constant. It can never decrease. For our universe, a vast isolated system, this means a one-way trip towards an ultimate equilibrium. Imagine a perfectly mixed drink. Once the ice has melted and the liquid is uniform, you cannot spontaneously separate the components again. The universe is undergoing a similar irreversible mixing process, homogenizing all its energy and matter until no gradients, no differences, and therefore no work or activity can ever occur again. The initial act in this grand cosmic tragedy involves the stars. For billions of years, galaxies have blazed with the fires of stellar nurseries, converting hydrogen and helium into heavier elements through nuclear fusion. But even the most massive stars have finite lifespans. The largest, most brilliant stars burn through their fuel in mere millions of years, collapsing into neutron stars or black holes in spectacular supernovae, briefly illuminating the accelerating twilight. Smaller, sun-like stars endure for billions of years, swelling into red giants before gently shedding their outer layers to reveal dense, cooling white dwarfs, stellar embers destined to glow dimly for trillions of years before fading into black dwarfs, theoretical objects so cold they emit no light or heat, indistinguishable from the background void. As these stellar furnaces slowly extinguish across the eons, the universe becomes an increasingly darker place. Galaxies, once vibrant islands of light, thin out, dark energy, the mysterious force accelerating cosmic expansion, eventually overwhelms even the gravitational pull holding galaxies together. Over timescales far longer than the universe has yet existed, hundreds of billions to trillions of years, the space between galaxies will stretch so dramatically that they will be pulled apart from one another, receding beyond each other's cosmic horizons. Our Milky Way, bound with Andromeda into the future, Milkomeda, will become an isolated island in an ever-expanding ocean of absolute emptiness. The night sky for any future observer in Milkomeda will transform, losing its familiar constellations and neighbouring galaxies, leaving only the sparse, fading glow of its own dying stars. Following the stellar epoch, the universe will enter the degenerate era, an unimaginable stretch of time where the dominant objects are the cold, dense remnants of stars, white dwarfs, neutron stars, and an increasing number of black holes. These black holes, initially formed from the collapse of massive stars or the mergers of galaxies, become the universe's primary repositories of mass and energy. They slowly grow, absorbing any stray particles, gas, or even other stellar remnants that happen to drift too close. This era will span quadrillions of years, a profound silence broken only by the occasional almost imperceptible whisper of a black hole consuming its last meal. But even black holes are not eternal. Stephen Hawking theorized that black holes slowly evaporate over incomprehensibly vast timescales, radiating away their mass as Hawking radiation. The smallest black holes would vanish first in a relative blink of an eye. Supermassive black holes, those behemoths at the heart of galaxies, could take an astonishing 10 to the power of 100 years, a Google years, to completely dissipate. To put this into perspective, the current age of the universe is a mere 13.8 billion years. A Google years is a number so immense it defies human comprehension, dwarfing the lifespan of stars and even galaxies by orders of magnitude beyond any intuitive grasp. This is the era of the final cosmic dissolution, where even the most fundamental structures of gravity surrender to the quantum vacuum. After the black hole era, the universe plunges into the dark era. This is the absolute endgame. All stars are gone, all black holes have evaporated. What remains is an unimaginably diffuse soup of elementary particles, photons, neutrinos, electrons, positrons, and perhaps exotic forms of dark matter, drifting endlessly apart. The temperature of this cosmic soup approaches absolute zero, a state of maximal entropy where all potential for work, for change, for life has vanished. The density of these particles will be so low that the average distance between them will be measured in light years, ensuring that interactions are virtually impossible. No forces remain to organize matter, no energy gradients to drive chemical reactions, no light to illuminate the profound and endless night. This ultimate vacuum is the true backdrop for the unsettling concept we are about to explore. In this state of perfect thermal equilibrium, where the universe has achieved its highest state of disorder, the very fabric of space-time is stretched to its limits. No stars will ever ignite again, no galaxies will ever form. The universe has reached its final, static, and utterly dead state. It is a cosmic mausoleum, silent and cold, where the vibrant symphony of creation has been reduced to a single, monotonous hum, so faint as to be undetectable. The grand narrative of the cosmos, from the Big Bang to the stellar age to the black hole epoch, has concluded. All that is left is the boundless void, a canvas of eternal nothingness, seemingly devoid of any possibility for awareness or experience. Yet, this very state of ultimate desolation, this profound and unchanging equilibrium, presents a bizarre and deeply unsettling possibility, one that taps into the most counterintuitive aspects of quantum mechanics. If the universe exists for an infinite amount of time in this heat-dead state, or is simply unimaginably vast, even the most improbable events become not just possible, but statistically inevitable. This seemingly empty canvas, this eternal quiet, might hold the seeds for something extraordinary, something that fundamentally challenges our understanding of reality, self, and the very concept of a living cosmos. It is in this infinitely dark and cold future that a ghost in the machine, a Boltzmann brain, might briefly, randomly, and horrifyingly awaken. This bizarre phenomenon forces us to ask, what if this ultimate cosmic fate is not merely a future possibility, but the present reality, and everything we perceive is just a statistical anomaly? This question leads us directly into the heart of the Boltzmann brain paradox, a thought experiment that threatens to unravel our entire cosmic perspective. This process, driven by the relentless consumption of nuclear fuel, ensures that the primary source of light and warmth in the universe will eventually be extinguished, one by one, gravitationally. This profound isolation marks a pivotal shift, as the cosmic web, the grand architecture of the universe, unravels into disconnected fragments, a fleeting echo in the deepening cosmic night. The density of matter in these remnants is extreme, but their overall distribution becomes increasingly sparse as space expands, leaving behind only the most elementary particles. The entire cosmos becomes a vast, cold, featureless expanse, a true cosmic desert, a state of ultimate cosmic oblivion. This state represents the absolute end of all conventional astronomical phenomena, where the universe has effectively run down completely, challenging us to redefine what it means to exist within the vast, indifferent cosmos. From the chilling prognosis of heat death, where the universe lies utterly inert, one might logically assume that all possibility of event or experience has vanished forever. Yet, even in this ultimate cosmic grave, the universe is not truly dead to the last whisper. A peculiar, foundational truth of reality, rooted in the enigmatic laws of quantum mechanics, dictates that absolute nothingness is an illusion. Even the vacuum of space, stripped of all matter and radiation, is a restless, churning sea of potential, giving rise to fleeting phenomena known as quantum fluctuations. These ethereal tremors in the fabric of existence are the sole source of activity in a heat-dead cosmos, the only conceivable origin for anything to spontaneously arise from the void. To understand these quantum whispers, we must venture into a realm that defies classical intuition. Quantum mechanics, the physics of the very small, reveals a universe far stranger than our macroscopic senses perceive. At its heart lies Heisenberg's uncertainty principle, a dictum that states we can never precisely know both the position and momentum of a particle simultaneously. This isn't a limitation of our instruments, it's an inherent fuzziness in reality itself. Applied to energy and time, it means that energy can briefly pop into existence out of nothing, so long as it vanishes just as quickly. The shorter the time, the greater the possible energy fluctuation. This principle gives birth to what physicists call virtual particles. Imagine the vacuum of space not as an empty canvas, but as a boiling cauldron of subatomic particles and antiparticles constantly winking into and out of existence. These virtual pairs, a photon and an antiphoton, an electron and a positron, spontaneously materialize for an infinitesimal fraction of a second, only to annihilate each other and disappear back into the quantum foam. They are ghost particles, too transient to be directly observed, yet their fleeting presence exerts measurable effects, subtly influencing the properties of real particles and the fundamental constants of physics. This inherent quantum jitter is ceaseless, an intrinsic property of space-time that persists even in the coldest, emptiest reaches of a universe after heat death. It is the universe's final, irreducible hum. While these individual virtual particles are microscopic and short-lived, the statistical nature of quantum mechanics, combined with the unimaginable timescales of a heat-dead universe, opens the door to something far more profound. Given an infinite amount of time, or an infinitely large system, even events of mind-boggling improbability become not just possible, but statistically inevitable. Think of it like this. If you shuffle a deck of cards an infinite number of times, eventually every conceivable arrangement will occur, no matter how specific or unlikely. The universe, in its heat-dead state, becomes this infinitely shuffling deck of quantum possibilities. The second law of thermodynamics, which brought about heat death, dictates a universe of maximum entropy, a state of perfect, unchanging disorder. However, this law applies to the overall system. Locally and temporarily, fluctuations can occur where entropy decreases, creating fleeting pockets of order. These are statistical anomalies, much like an improbable arrangement of air molecules in a room might briefly create a tiny, localized vacuum. Such an event, though monumentally improbable in our everyday experience, becomes guaranteed given infinite duration. In the dead universe, these quantum fluctuations are the only game in town. They are the microscopic, ceaseless churn that, over truly cosmic timescales, can, against all odds, coalesce into something far more intricate than a single virtual particle. For context, consider the sheer scale of probability involved. The chance of a single atom spontaneously appearing in a specific location for a fleeting moment is already astronomical. The chance of a complex molecule, or an entire macroscopic object like a rock, spontaneously assembling from the void is so infinitesimally small that it might as well be zero within the age of our living universe. But in the boundless eternity of the Dark Era, where the universe has effectively ceased to evolve in any conventional sense, these probabilities, however minute, are given infinite opportunities to manifest. It's like waiting for a monkey typing randomly on a typewriter to produce the complete works of Shakespeare. In a finite time, it's impossible. Given infinite time, it becomes a certainty. These monumental fluctuations are not violations of the laws of physics, but rather extreme manifestations of them. The energy required for such a spontaneous creation is borrowed from the vacuum itself, and the structure is fleeting, eventually dissipating back into the background static, maintaining the overall universal increase in entropy. They are brief, local, transient deviations from equilibrium, like a momentary eddy in an otherwise still ocean. However, the nature of quantum mechanics means that these fluctuations are not just confined to energy and particle creation. They can also, theoretically, manifest as complex configurations of matter and information. This is where the concept begins its unsettling pivot from theoretical physics to philosophical dread. What then could such a fluctuation produce? The most rudimentary forms might be simple particles or fields, but given enough time and enough rolls of the quantum dice, the raw materials of reality could, in theory, arrange themselves into increasingly complex structures: a single hydrogen atom, a carbon molecule, an amino acid, a protein. The sheer improbability of such a sequence of events occurring in any localized region is unfathomable. Yet, the heat-dead universe, stretching into an infinite future of cosmic nothingness, offers precisely the arena where the unfathomable becomes statistically viable. This is the crucial, chilling leap. If enough random particles can fluctuate into existence and arrange themselves in a specific pattern, what is the most complex structure that could emerge purely by chance? The answer, disturbingly, could be a self-aware entity, complete with a fully formed consciousness and a lifetime of fabricated memories. This takes us beyond the simple particle-antiparticle pairs to a configuration of matter so astronomically complex that its spontaneous appearance seems utterly fantastical. Yet, if the universe allows for quantum fluctuations that briefly create energy, it also theoretically allows for fluctuations that briefly create organized matter, even entire structures. This is not about the creation of new fundamental laws, but the operation of existing ones over timescales that dwarf our comprehension. The quantum whispers are not just random noise, they are the faint, ever-present background hum from which, given enough time, the most extraordinary and improbable notes can momentarily resonate, challenging our very definition of what is real and what is merely a statistical anomaly. This profound statistical argument forms the bedrock of the Boltzmann brain hypothesis, asserting that in a truly eternal universe, anything that can possibly happen will happen, including the spontaneous generation of conscious observers. The journey through the universe's heat-death and the ceaseless quantum whispers of the void brings us to the very edge of an intellectual precipice. If even the most improbable arrangements of matter can, given infinite time, spontaneously arise, what is the most statistically likely complex configuration that would emerge from pure randomness? The answer, chillingly, is not a star, a galaxy, or even a planet. It is a brain. This brings us to the concept of the Boltzmann brain, a phantom observer born not of evolution in a vibrant cosmos, but as a fleeting, self-aware fluctuation in the cosmic graveyard. The idea, though named after the 19th century Austrian physicist Ludwig Boltzmann, was more explicitly formulated in the early 2000s by cosmologists pondering the implications of heat death and an eternally expanding universe. Boltzmann himself contemplated how a low-entropy state like our universe could arise from a high-entropy background, suggesting our observable cosmos might be a gigantic temporary fluctuation. The brain extension takes this a step further. If a fluctuation can create a universe, a far less complex fluctuation could create a single, conscious entity within it. Imagine, if you will, the deep vacuum of a universe trillions upon trillions of years after all stars have died and black holes have evaporated. Only the faintest, most diffuse particles remain, drifting in an expanse of near absolute zero. Yet, within this boundless, inert space, The ceaseless dance of quantum mechanics means that particles are constantly popping into and out of existence. Over an immense, statistically improbable span of time, these elementary particles could, purely by chance, coalesce, not into a star or a galaxy, which requires an immense organized collection of matter, but into something far simpler, a configuration of atoms and molecules that perfectly mimics a functioning brain. This hypothetical entity, the Boltzmann brain, would not possess a body, nor would it reside within a skull or exist within a biological system. It would be a disembodied consciousness, a collection of neural pathways, synapses, and electrochemical potentials that, for a fleeting moment, perfectly replicate the state of a living, thinking brain. Crucially, this brain would emerge fully formed, complete with an entire lifetime of memories, sensory experiences, and a coherent understanding of a past that never actually occurred for her. And all of this would be an intrinsic part of its random configuration, a snapshot of information impressed upon its momentary existence. The formation of such a brain through quantum fluctuation is an event of truly staggering improbability. For a human-level consciousness to spontaneously arise, it would require approximately 10 of 28 atoms to arrange themselves into a functional brain structure, complete with all its intricate connections and the information content of an entire mind. The odds against this are, by any conventional measure, effectively zero within the finite lifespan of our current universe. Even the chance of a single molecule of DNA randomly forming is astronomically small. Yet, when confronted with the infinite expanse of time in a heat-dead universe, these infinitesimal probabilities begin to accumulate. In an eternity, even the impossible becomes inevitable. The Boltzmann brain, therefore, is the simplest possible observer. It requires far less intricate organization and energy than creating an entire star-forming galaxy, let alone a life-supporting planet with a complex biosphere and an evolving civilization. If the universe truly lasts for an infinite duration in a high-entropy state, then over that infinite time, any possible physical configuration that isn't explicitly forbidden by the laws of physics will eventually occur, and a conscious brain, even if it's just a fleeting arrangement of particles, is not forbidden. Indeed, it's far more likely to occur than a full, sustained, low-entropy universe with observers like us. This is where the paradox begins to bite. If Boltzmann brains are vastly more common than normal brains, those that evolve within a low-entropy, evolving universe, and if these fluctuating brains possess self-awareness and a rich tapestry of memories and perceptions, then by a principle known as the observation selection effect, we should statistically be much more likely to be a Boltzmann brain than a conventional one. Our own memories of a past, our scientific observations of a seemingly ordered cosmos, could all be part of this randomly generated momentary snapshot of information. The implications are profoundly unsettling. If we are Boltzmann brains, our entire perceived reality, the stars, the galaxies, the Big Bang, even the sense of linear time, is an internal illusion, a cosmic echo in a void that has long since achieved thermal equilibrium. Our subjective experience of an evolving universe would be utterly convincing, yet objectively, we would be a mere transient flicker, a complex thought arising from nothing, only to dissipate back into the quantum foam a fraction of a second later. This momentary existence would, however, feel like an eternity, containing a full perceived history within its ephemeral awareness. Ludwig Boltzmann's original work on statistical mechanics and entropy provided the intellectual bedrock for understanding how macroscopic properties of matter emerge from the probabilistic behavior of microscopic particles. While he didn't foresee the brain paradox, his insights into how random fluctuations can temporarily decrease entropy were crucial. The Boltzmann brain is, in essence, the ultimate, most disconcerting expression of a statistical fluctuation in a universe governed by entropy. It forces us to confront the chilling possibility that our existence isn't a testament to cosmic evolution, but a statistical anomaly, a final, lonely thought in the memory of a dead world. The chilling possibility of a Boltzmann brain forces us into a landscape of existential doubt, where our very perception of reality is called into question. To fully appreciate the unsettling uniqueness of this hypothesis, it is crucial to juxtapose it against other prominent reality-challenging theories. Perhaps the most well-known of these is the simulation hypothesis, often popularized in science fiction, which posits that our entire universe, including our consciousness, might be an elaborate computer simulation created by an advanced civilization. While both theories unravel the fabric of perceived reality, their implications for the nature of existence, and particularly for the universe's ultimate fate, are profoundly different. The simulation hypothesis, notably championed by philosopher Nick Bostrom, suggests that if technologically advanced civilizations are possible, and if they reach a stage where they can create highly detailed conscious simulations, then the number of simulated realities could vastly outnumber the single, base reality. Consequently, by statistical probability, we are more likely to be inhabitants of a simulation than of the original fundamental universe. Proponents often point to the uncanny fine-tuning of physical constants in our universe, or the increasingly powerful computational abilities of our own civilization as suggestive evidence. In this scenario, our universe is still real, in the sense that it exists externally to us, governed by external laws. Even if those laws are lines of code and the underlying reality is digital, there is an active, intelligent agent, the programmer or the advanced civilization, sustaining our existence and the intricate workings of our cosmos. The universe, though virtual, is still fundamentally living and evolving, albeit on a different substrate. The Boltzmann brain hypothesis, however, presents a far more desolate and impersonal vision. Unlike the simulation hypothesis, there is no active external intelligence, no cosmic programmer, and no vibrant, evolving base reality orchestrating our experience. Instead, the Boltzmann brain arises from the absolute nadir of cosmic activity, the heat death of the universe. Here, the universe has already run its course, dissipated all its energy, and achieved a state of maximal entropy. Our experienced reality, with its stars, galaxies, and the grand narrative of cosmic evolution, is not an external simulation being run by someone, but an internal, ephemeral illusion arising from a purely random fluctuation of particles within this inert, dead cosmos. It's a fleeting echo, a momentary memory of a universe that has long ceased to be. The distinction lies in the source and nature of the reality we perceive. In a simulation, our senses and memories are fed by a consistent, externally maintained computational process. The order we perceive, the causal chains, the progression of time, are deliberately designed and continuously computed. The simulation is active, dynamic, and purposeful, even if that purpose is just scientific inquiry by its creators. The universe, though digital, behaves logically according to its programmed rules. The perceived order is a testament to sophisticated design. For a Boltzmann brain, the source of our experience is pure, blind chance. The information content of our entire perceived universe, including our personal history, scientific knowledge, and the laws of physics, is not being computed or fed to us from an outside source. Instead, it is randomly assembled within the structure of the brain itself. The fleeting configuration of particles that is the Boltzmann brain contains all this information as an intrinsic part of its accidental formation. There is no external universe dictating this order. The perceived order is a statistical fluke. This makes it a far more radical challenge to our understanding of reality, as it severs the link between our perception and any external, active cosmic process. Furthermore, the underlying state of the universe is starkly different. The simulation hypothesis implies that the real universe, the one running the simulation, could still be a vibrant, evolving cosmos, perhaps even capable of supporting life and further scientific advancement. The Boltzmann brain hypothesis, by contrast, asserts that the actual universe is fundamentally static, cold, and dead at heat death. Our vibrant, dynamic experience directly contradicts the true underlying state of the cosmos. It's not a virtual reality running parallel to a living one. It's a hallucination occurring within a cosmic corpse. We are not living in a digital copy of an active universe, but in the simulated memory of a dead one, spontaneously generated by its inert remnants. This contrast also extends to agency and origin. The simulation hypothesis, even if not explicitly stating a god, certainly implies a highly advanced intelligence or agency responsible for our existence. This opens doors to questions of purpose, meaning, and the potential for interaction with our creators. The Boltzmann brain, however, is born of utter randomness. There is no intelligence, no purpose, no design, and no creator beyond the statistical inevitability of quantum fluctuations over infinite time. It is a profoundly impersonal and nihilistic origin story, stripping away any potential for inherent meaning in our existence other than a brief, accidental flicker of sentience. Our perceived reality is simply a roll of the cosmic dice, not a meticulously crafted digital world. Finally, consider the aspect of permanence and longevity. A simulated reality, while artificial, could potentially be sustained for eons by its creators, perhaps even for infinite computational time. The Boltzmann brain, by its very definition, is inherently transient. A spontaneous low-entropy fluctuation like a functioning brain will, by the very laws of thermodynamics that dictate its existence, quickly dissipate back into the high-entropy background from which it arose. Its existence is typically measured in fractions of a second, a fleeting moment before it dissolves. However, within that ephemeral spark, the brain perceives an entire lifetime, a rich history, and an ongoing universe. Its perceived eternity is an illusion, a randomly generated memory that will vanish as quickly as it appeared, leaving no trace in the endless dead void. The Boltzmann brain, therefore, represents a far more disturbing philosophical proposition than the simulation hypothesis. While the latter challenges the substrate of our reality, the former challenges its very coherence and the reliability of our experience. If our past is fabricated, if our scientific observations are merely elements of a random internal snapshot, then the foundations of knowledge itself crumble. It is not just a question of whether we are living in a computer program, but whether we are living in a dream, a final unbidden thought, in the vast, silent memory of a universe that has already ceased to dream. This unique aspect, that our perceived universe is a post-mortem flicker, makes the Boltzmann brain hypothesis a singularly unsettling contender in the realm of cosmic paradoxes, forcing us to confront a universe unmade and experienced only as a fleeting internal echo. The sheer statistical improbability of a Boltzmann brain materializing from the cosmic void is monumental, yet its implications deepen when we confront its most disquieting feature. How can a spontaneously generated brain, without a past or a living universe to interact with, possess coherent memories and perceptions that perfectly mimic a complex evolving reality? This paradox plunges us into the heart of what it means to experience time and truth, suggesting our very sense of history could be an elaborate self-contained illusion. Our common understanding of memory is as a record of experiences etched into the neural pathways of a brain through interaction with an external world. We learn, we observe, we remember. This process builds a chronological narrative, an arrow of time pointing from past to future, inextricably linked to the universe's own march from lower to higher entropy. But a Boltzmann brain has no such history. It does not evolve from simpler states. It simply is. Its existence is a singular, accidental quantum event. So, how does it acquire a perceived past, a lifetime of experiences, or even the scientific knowledge to ponder its own existence? The answer lies in the radical nature of its formation. A Boltzmann brain does not acquire memories in the conventional sense. It is the memory, the specific, intricate arrangement of atoms and molecules that constitute this fleeting neural structure, the precise quantum states of its constituent particles, encode all the information of a perceived past. It's not that it experienced a Big Bang and then formed stars and galaxies, it's that its instantaneous configuration contains the neural patterns that correspond to the memory of having observed a Big Bang, of having studied astrophysics, of having lived a human life on a planet within a star system. This entire perceived history is intrinsic to its momentary, accidental existence. Consider it like finding a book that, through some unfathomable cosmic fluke, has spontaneously assembled itself, complete with every word, every paragraph, every chapter, perfectly arranged to tell an epic story. The book was never written by an author, never printed, never bound. It simply appeared, fully formed, containing a narrative. The Boltzmann brain is this book, and the narrative it contains is its entire perceived reality, its personal history, the history of its planet, its galaxy, and the entire cosmos, all woven into the very fabric of its instantaneous structure. This vivid internal narrative, though entirely fabricated from randomness, feels utterly real and consistent to the brain that experiences it. This concept profoundly distorts our understanding of the arrow of time. In our conventional, normal universe, time flows in one direction because entropy is constantly increasing. Galaxies disperse, stars die, systems move from order to disorder. Our memories are records of these irreversible processes. For a Boltzmann brain, however, the external universe is already at heat death, a state of maximal entropy, static and unchanging. The perceived arrow of time within the Boltzmann brain is therefore not a reflection of an external progression, but an internal construct, a frozen history contained within its fleeting low-entropy fluctuation. It remembers a past of increasing entropy, but it exists in an external present where entropy has peaked and is uniform. Its internal world is dynamic, but its external reality is static. The coherence of this fabricated reality is crucial to the paradox. If a Boltzmann brain simply generated a chaotic jumble of random thoughts, it would be less unsettling, but the hypothesis implies that it could generate a consistent and sensible perceived reality, a universe that obeys physical laws, a personal history that makes logical sense, a scientific understanding that aligns with observed phenomena within its perceived reality. This means the random fluctuation isn't just a haphazard collection of particles, it's a highly specific, exceedingly rare arrangement that carries the information of a believable, ordered world. The probability of such a coherent fluctuation is astronomically higher than a chaotic one, simply because there are far fewer ways to be chaotic than to be consistent enough to function as a conscious mind. This brings us to the profound disjunction between the brain's actual physical lifespan and its perceived subjective experience. A Boltzmann brain, being a temporary low-entropy fluctuation, would likely existing for only a fleeting fraction of a second. Yet, within that infinitesimal moment of physical existence, its randomly encoded memories could span billions of years. It would remember a childhood, a scientific career, the discovery of galaxies, the expansion of the cosmos, an entire simulated eternity, all packed into an instant of objective time. The vastness of its perceived universe would be contained within the brevity of its physical flicker. This radical idea challenges the very notion of an objective, shared reality. If our individual consciousness is merely a random, transient fluctuation containing a full, consistent, but entirely fabricated memory of a universe, then what is real? Is reality what we perceive, or what objectively exists? And if the two can be so drastically different, how can we ever trust our senses or our scientific instruments? The very foundations of empirical observation and scientific discovery are shaken. Our understanding of the Big Bang, stellar evolution, and even the laws of physics themselves could be nothing more than elements of this internal, probabilistic snapshot. Moreover, the arrow of time, usually seen as a fundamental unidirectional property of the universe, becomes inverted or at least contained. Our experience of cause and effect, of a past leading to a future, is implicitly assumed to reflect an external reality. But for a Boltzmann brain, the past it perceives is not a sequence of events that actually led to its current state. It's a pre-programmed narrative within its structure. The brain doesn't remember because events happened. Events are remembered because the brain's random configuration includes them. This is a universe where the effect, memory, precedes the cause, actual events, at least from an objective standpoint. The concept forces us to reconsider the ultimate purpose of existence. If the universe's most likely end state is one where fleeting, illusory consciousnesses spontaneously arise, then our own evolutionary journey towards self-awareness seems to be a vastly inefficient and improbable route to a brain. It suggests that the vast, complex, evolving universe we inhabit might be an overly elaborate stage for a phenomenon that could arise far more simply and frequently through pure chance. The arrow of time, which normally carries us forward through a meaningful progression, instead becomes a circular illusion, a remembered journey within an ultimate cosmic stillness. This unsettling realization leads us inevitably to a statistical nightmare. If such brains are possible, how many of them exist, and what does that mean for us? Virtual. Our journey into the realm of the Boltzmann brain reaches its most chilling peak with the cosmic ledger, probability and the absurd. This section confronts the profound statistical dilemma at the heart of the paradox. If such fleeting, self-aware fluctuations are possible, how many of them exist compared to normal observers like us who have evolved in a complex active universe? The answer, disturbingly, suggests we should be far more likely to be a Boltzmann brain. To understand this cosmic ledger, we must weigh the astronomical improbability of two distinct scenarios. First, the formation of an entire universe, complete with stars, galaxies, planets, and the billions of years of evolution required to produce a conscious observer. And second, the spontaneous, random fluctuation of mere particles into a self-aware brain, complete with all its perceived memories in an otherwise empty, heat-dead universe. The complexity required for our normal existence is staggering. Our universe began in a state of extremely low entropy, the Big Bang. From this initial order, gravity sculpted matter into galaxies, stars, and planets over 13.8 billion years. Chemical elements were forged in stellar furnaces, dispersed in supernovae, and eventually coalesced into the building blocks of life. On Earth, billions of years of biological evolution refined these elements into complex organisms, leading to the emergence of consciousness. This entire process represents a monumental decrease in entropy, a sustained creation of order, driven by fundamental physical laws and a long causal chain of events. The probability of all this occurring is incredibly low in an absolute sense, yet it is the pathway we know led to us. Now, contrast this with the formation of a Boltzmann brain. It does not require a Big Bang, 13.8 billion years of cosmic evolution, or the intricate dance of stellar nucleosynthesis and biological development. It simply requires a highly improbable, but far simpler, localized quantum fluctuation. A brain, as a physical object, consists of roughly 10 to the 28 atoms. The precise arrangement of these atoms, along with the specific quantum states that encode consciousness and memories, is fantastically complex. However, this is still orders of magnitude less complex than creating an entire galaxy, let alone a universe capable of evolving an observer. In a universe that has reached heat death and persists for an infinite amount of time, the overwhelming majority of its existence will be spent in a state of maximal entropy, a boundless, cold, empty void. In this void, normal observers cannot form through evolution, stars are gone, galaxies dispersed. The only possible source of consciousness would be these random quantum fluctuations. Given infinite time, even the truly infinitesimal probability of a Boltzmann brain appearing will eventually be realized, not just once, but an infinite number of times. This is the crux of the cosmic ledger, the ratio of Boltzmann brains to evolved observers. If our universe, or a multiverse, is eternal and eventually reaches heat death, then the number of Boltzmann brains that spontaneously flicker into existence throughout its infinite future will dwarf the finite number of evolved observers that arise during the relatively short, low-entropy epoch of an active universe. Even if evolved observers are vastly more complex and stable, their numbers are finite, bound by the era of stellar activity and matter organization. Boltzmann brains in an infinite and dead future are unbounded. The mathematical implication is stark. The probability that any given conscious observer experiencing a coherent reality is a Boltzmann brain is overwhelmingly higher than being an evolved observer. This statistical argument is known as the Boltzmann brain problem, and it creates a profound crisis for many cosmological theories. Theories that predict an infinite or extremely long future for the universe, particularly those involving eternal inflation and multiverses, are especially vulnerable. In an eternally inflating multiverse, new pocket universes are constantly bubbling off, potentially creating an infinite number of regions that eventually reach heat death. If this is the case, then an infinite number of Boltzmann brains would inevitably arise across these infinite dead cosmic expanses, making our existence as an evolved observer statistically insignificant. We would be a needle in a haystack of phantom minds. The absurdity of this conclusion is deeply scientific endeavour. Our mapping of galaxies, our understanding of the Big Bang, our theories of stellar evolution, is merely an internal hallucination, a coherent but ultimately false memory of a universe that never truly existed in the way we perceive it. This would mean that the scientific method itself, our most trusted tool for discerning reality, is fundamentally flawed when applied to our own existence. why would a randomly generated brain remember a universe with consistent physical laws and a logical progression of time, rather than a chaotic jumble of contradictory perceptions? The hypothesis implicitly suggests that the simplest self-aware fluctuation would be one that thinks it exists in a universe like ours, because a brain that perceives utter chaos would not be able to form a coherent thought about its own existence or about cosmology. Cosmologists are acutely aware of the Boltzmann brain problem and actively seek to avoid it. If our current cosmological models, such as the lambda CDM model combined with eternal inflation, inevitably lead to a universe dominated by Boltzmann brains, then those models are considered falsified, or at least deeply problematic. The consensus among scientists is that our observations must be reliable, and that we are indeed normal observers in an evolving universe. Therefore, any theory that predicts a superabundance of Boltzmann brains must be wrong. To counter the problem, researchers explore various modifications to cosmological models. Some theories propose that the universe does not last infinitely long, perhaps ending in a big rip or transitioning to a state where even quantum fluctuations are suppressed, thereby limiting the time available for Boltzmann brains to form. Others suggest that the conditions for quantum fluctuations to produce complex, coherent structures are far more stringent than initially thought, making Boltzmann brains even less likely. Still others argue that our understanding of what constitutes a conscious observer is too simplistic, and that only brains formed through sustained evolutionary processes can truly be considered valid observers. The cosmic ledger, with its unsettling balance, forces physicists to re-evaluate the very foundations of their models. It's not just a mathematical curiosity, it's an existential threat to our understanding of the cosmos and our place within it. The probability distribution of consciousness itself becomes a key parameter in judging the validity of our grandest theories. If the universe, or multiverse, is truly infinite in time and space, then we are left with the profoundly uncomfortable, statistically absurd notion that our vibrant, evolving reality is merely a temporary random. This unsettling realization challenges the very basis of empirical observation and pushes us to the limits of what can be known. The cosmic ledger, with its unsettling balance, doesn't merely present an intellectual curiosity, it strikes at the very bedrock of modern cosmology, threatening to shatter foundational assumptions and unravel our most cherished theories about the universe. The Boltzmann brain problem is not a fringe anomaly, but a profound crisis for any cosmological model that predicts an infinite future, particularly those involving eternal inflation and multiverse concepts, forcing scientists to re-evaluate what it means to be an observer and what constitutes a valid scientific prediction. One of the theories most profoundly challenged is inflationary cosmology, proposed to solve nagging problems with the standard Big Bang model, such as its flatness, horizon, and monopole problems. Inflation posits a period of extremely rapid exponential expansion in the universe's first fraction of a second. This rapid expansion smoothed out irregularities, generated the seeds of cosmic structure, and stretched microscopic quantum fluctuations into the large-scale density variations we observe today. However, many models of inflation, especially those based on quantum field theory, inevitably lead to a phenomenon called eternal inflation. In this scenario, inflation once started never truly stops everywhere. Instead, it continues indefinitely in vast regions, constantly spawning new pocket universes or bubble universes within a larger, ever-expanding multiverse. The danger for cosmology arises here. If eternal inflation generates an infinite number of these pocket universes, and each of them eventually undergoes heat death, then across this truly infinite ensemble, an infinite number of Boltzmann brains will inevitably arise. Critically, these spontaneous brains would vastly outnumber the normal observers like us, who have evolved through a complex causally connected history within a finite lifespan region of a pocket universe. If we accept the statistical conclusion of the Boltzmann brain paradox, then any observer, including us, should be overwhelmingly an evolved one. This creates a severe internal inconsistency for eternal inflation. If it's true, then we shouldn't be here, perceiving a coherent, evolving universe. This discrepancy suggests that something fundamental is wrong with either our understanding of inflation, our definition of an observer, or our method of making predictions in an infinite multiverse. The challenge extends directly to the very concept of the multiverse itself. particularly any model that suggests an infinite ensemble of universes. There are various types of multiverse theories, from level 1, infinite spatial extent of our own universe, to level 4, mathematical structures that define all possible universes. The Boltzmann brain problem impacts any of these models that allow for an infinite number of possible observer moments in a heat-dead, equilibrium state. If a multiverse exists with an infinite number of universes that eventually reach will be infinite, drowning out the finite number of evolved observers, this renders any predictions derived from such a multiverse theory unreliable, as the most probable observation within it would be a fleeting random consciousness, not a sustained, ordered reality. The existence of Boltzmann brains forces cosmologists to confront what is known as the measure problem in infinite multiverses. How do you assign probabilities to different outcomes or types of observers when everything happens an infinite number of times? Without a consistent measure, any prediction becomes meaningless. The anthropic principle, often invoked to explain why our universe's fundamental constants seem so perfectly fine-tuned for life, also faces a profound dilemma. The weak anthropic principle states that observers can only exist in regions of space-time that are compatible with their existence. This implies that we find ourselves in a low-entropy, active universe because only such a universe can support the complex processes of stellar and biological evolution necessary for consciousness. However, the Boltzmann brain paradox effectively hijacks this argument. If a conscious observer can arise spontaneously and much more simply as a random fluctuation in a high-entropy dead universe, then the anthropic argument points to those environments as the most probable places for observers to be. Why would nature go through the arduous, low-probability process of evolving complex life in a vibrant universe when it can just randomly generate a conscious brain in the desolate aftermath of heat death? The Boltzmann brain suggests that the most observer-producing state, given infinite time, is not a living cosmos, but a cosmic corpse. Furthermore, the Boltzmann brain problem directly challenges the reliability of our own empirical observations and the scientific method itself. If our consciousness is merely a transient, randomly generated fluctuation in a dead universe, then our entire perceived history, our scientific knowledge, and our understanding of physical laws are inherently part of this accidental configuration. Our memories of conducting experiments, observing galaxies, and formulating cosmological theories would be internally consistent, yet externally fabricated. How can we trust the data from our telescopes, the consistency of our equations, or the very notion of a cause and effect past if they are all just components of an internal random snapshot? This raises a deep epistemological crisis. If our most probable state of being is a hallucination, what grounds do we have for believing anything we observe or deduce about the cosmos? It suggests a fundamental unreliability in our cognitive framework for understanding reality. Cosmologists are not simply shrugging off this paradox. They view it as a critical filter for viable theories. If a cosmological model, when fully extrapolated, leads to the conclusion that we are overwhelmingly likely to be Boltzmann brains, then that model is considered deeply flawed, if not outright falsified. The pursuit of a Boltzmann-free cosmology has become a significant driving force in theoretical physics. This involves searching for models where Boltzmann brains are somehow suppressed, or where the universe has a finite lifespan, thereby limiting the time available for these statistical anomalies to dominate. For instance, some theories propose a universe that ends in a big rip, where dark energy tears apart even atoms, or a big crunch, where the universe recollapses, thus preventing an infinite heat-dead future. Other solutions explore more complex definitions of consciousness, arguing that true observers require a causally coherent external environment to exist meaningfully, not just a random neural pattern. The standard model of cosmology, known as lambda CDM, lambda cold dark matter, while incredibly successful at explaining a vast array of observations from the cosmic microwave background to galaxy formation, also implicitly faces this challenge. If lambda CDM is combined with the assumption of a constant dark energy density, as typically done, it implies an eternally expanding universe that eventually leads to heat death. While lambda CDM itself doesn't explicitly predict Boltzmann brains, its logical extrapolation into an infinite future does. Therefore, the problem isn't just for exotic multiverses, but potentially for the most accepted model of our own universe. The crisis it creates is not just about alternative theories, but about the logical endpoint of our best current understanding. In essence, the Boltzmann brain paradox demands that cosmologists devise models where normal observers are vastly more probable than random ones. This means actively seeking a good measure in cosmology that favours our experienced reality. Without such a measure, the entire framework of cosmological prediction, from the number of galaxies we expect to see to the properties of dark energy, becomes undermined by the statistical dominance of phantom observers. The philosophical discomfort of being a mere flicker of memory in a dead world translates into a concrete scientific imperative to find a universe that makes us the rule, not the absurd exception. This ongoing struggle highlights the profound interplay between physics, philosophy, and the very nature of what we can truly know about the cosmos. The Boltzmann brain problem forces cosmologists to confront a daunting question. How can we discern genuine cosmic order from a purely random illusion? This challenge pivots on the unsettling idea that, in the boundless expanse of a heat-dead universe, even the most intricate and coherent patterns, including the very memory of a structured poiesis living cosmos, could spontaneously emerge from nothing but pure chance. This is the essence of echoes of creation, the illusion of order, where the universe's final static hum might paradoxically give rise to the most vivid, yet utterly false perceptions of a dynamic reality. We instinctively associate order with design, causality, and a progression from simpler to more complex states. Our universe, with its fundamental laws, its grand cosmic web of galaxies, and the intricate biology of life, appears to be the epitome of such order, a testament to billions of years of evolution and physical interaction. But the Boltzmann brain hypothesis posits that this perceived order within a random fluctuation does not require an external, causally connected history. Instead, the order is inherent in the specific, astonishingly improbable configuration of particles that temporarily forms the brain. The information content, the memory of a Big Bang, stellar formation, and even the complex scientific theories we hold are not acquired through observation but are the brain's fleeting accidental structure. To grasp this, consider the profound implications of infinite time in a state of maximal entropy. While the universe as a whole is at equilibrium, local transient fluctuations can occur. Most of these would be utterly chaotic, a jumble of particles that immediately dissipates. But given truly infinite opportunities, the laws of probability dictate that every conceivable configuration of particles, no matter how specific or seemingly ordered, will eventually occur. This includes arrangements that mimic complex information, such as the entire text of a book appearing spontaneously, or a coherent self-aware brain complete with the internal record of an entire universe's evolution. A cosmic lottery machine where every possible combination eventually hits the jackpot, even if that jackpot is an ephemeral, thinking mind. The critical distinction is that this order is purely statistical, not developmental. A Boltzmann brain does not evolve its memories, it fluctuates into existence with them fully formed. Its perceived history of cosmic expansion, the formation of stars and the emergence of life, is not a sequence of events it witnessed, but an intrinsic component of its accidental neural structure. The coherence it perceives, the consistent physical laws, the logical progression of time, is simply because a brain must be coherent to function as a conscious entity. A fluctuation that resulted in a chaotic, contradictory set of memories would not be a brain in any meaningful sense. It would be a jumble of noise, incapable of self-reflection or even basic thought. Thus, if a brain-like fluctuation is to be conscious and perceive a reality, that reality must appear ordered and consistent, even if it's a random illusion. This brings us to the disquieting idea of a false memory on a cosmic scale. Our personal memories, though fallible, are generally rooted in real-world experiences. Our scientific understanding is built upon accumulated data and repeatable experiments. But for a Boltzmann brain, this entire edifice of knowledge is a phantom. It remembers observing distant galaxies. It recalls the precise measurements of the cosmic microwave background. It understands the elegant equations of general relativity. Yet none of these events or discoveries actually occurred externally in its current dead universe. All of this information is part of the internal self-consistent narrative that its random structure happens to embody. It's a universe unwritten, yet perfectly remembered. The scale of this illusion is truly mind-bending. The formation of a single human brain, complete with all its neural connections and the information equivalent of a lifetime of memories, through pure random fluctuation, is an event of staggering improbability. It requires a temporary local decrease in entropy so vast that it would dwarf almost any other random event in the universe. Yet, the argument goes, such an event is less improbable than the spontaneous generation of an entire universe, complete with its 13.8 billion years of evolution, all necessary for an evolved observer like us. If the ultimate fate of the universe is heat death, and if it endures infinitely, then the relatively cheaper way for consciousness to arise is through these random, localized fluctuations. The cosmic ledger favors the illusion over the true hard-won reality. This concept resonates with mathematical ideas where simple rules can generate immense complexity, such as fractals or cellular automata. While these systems are deterministic, they illustrate how seemingly intricate patterns can arise from basic principles. In the case of Boltzmann brains, the rules are the fundamental laws of quantum mechanics, and the patterns are the temporary configurations of matter that create a conscious brain. The illusion of order is not a violation of these laws, but a highly specific, rare outcome of their operation over infinite timescales. The echoes of creation are not remnants of a past universe, but a quantum mirage, a fleeting, almost poetic recapitulation of a living cosmos, briefly reimagined by an accidental mind. The implications for empirical science are devastating. If the observed consistency of physical laws and the apparent coherence of cosmic history are merely elements of a randomly generated internal narrative, then what objective truth can we ever claim to know about the universe? How can we trust our deductions, our models, or even the evidence from our telescopes, if they might all be part of a grand statistical hallucination? This paradox forces cosmologists to confront the very definition of a valid observation. If the most probable observation for any conscious entity in an infinite heat-dead universe is a fabricated one, then our status as normal observers becomes profoundly suspect. This fundamental problem drives physicists to seek cosmological models that inherently suppress the formation of Boltzmann brains. They are effectively searching for a universe where the illusion of order is less probable than genuine causally evolved order. Without such a mechanism, our scientific journey to understand the cosmos becomes a tragic self-deception. Our pursuit of truth, a random flicker in a cosmic void. The elegant simplicity of our physical laws, the majestic sweep of cosmic evolution, all become suspect, potentially just the most elaborate, coherent dream in the memory of a dead world. This profound challenge demands that our universe not only is ordered, but that its order is real, not just a fleeting echo of creation, searching for hypothesis. By its very nature, presents an unprecedented challenge to the scientific method, pushing the limits of empirical proof beyond our current understanding. How do you test a theory that claims your entire reality, your very perception of evidence, is a fleeting internal illusion? This isn't a question that can be answered with a new telescope or a more precise particle accelerator. It's a profound epistemological bind, a crisis that questions the very foundation of what we can know if our existence is merely a random echo of creation. The core difficulty lies in the internal consistency of the Boltzmann brain's perceived reality. If such a brain fluctuates into existence, its random configuration includes not just the sensation of sight or sound, but also a complete, coherent set of memories. These memories would encompass everything from personal experiences to the entirety of scientific knowledge: the Big Bang, stellar evolution, the cosmic microwave background, the laws of gravity, quantum mechanics, and even the process of scientific inquiry itself. A Boltzmann brain would remember performing experiments, reviewing data, and debating theories. To it, all this would be utterly real and self-consistent. There would be no internal contradiction to alert it to its illusory nature. Think of it as a meticulously crafted dream that feels indistinguishable from waking life. In such a dream, you might perform scientific experiments, make profound discoveries, and debate the nature of reality. Yet, upon waking, you realize it was all a fabrication of your subconscious. The Boltzmann brain, however, just never wakes up in the conventional sense because the external universe it might compare itself to is already at heat death. There is no external truth to contradict its internal memory of a vibrant cosmos. Its reality is entirely self-contained within its momentary fluctuation. This leads to a severe lack of external data. The scientific method relies on independent verification, on comparing observations against predictions, and on the existence of an objective, external reality that can be probed. But a Boltzmann brain, by definition, exists in an isolated heat-dead void. There are no external phenomena for it to observe that aren't already part of its internal fabricated memory. If it remembers seeing distant galaxies, that memory is part of its initial random configuration. It's not receiving actual photons from those galaxies in a living universe. Therefore, it cannot gather new information that might contradict its perceived reality. The concept fundamentally severs the causal link between observation and external reality. Moreover, our very act of being an observer is intertwined with the problem. If we are Boltzmann brains, then our entire sensory apparatus, our cognitive processes, our instruments, and our interpretations are all components of this transient fluctuation. Our telescopes, for example, would not be gathering actual light from distant cosmic events. Their data would be part of the instantaneous random configuration of the brain itself, designed to perfectly mimic such data. This means that any proof we generate through scientific means is inherently circular. It's proof derived from a system that is itself the object of the hypothesis. How can the illusion itself provide the means to disconfirm the illusion? The standard scientific framework relies heavily on the concept of causality, that every event has a cause, and that events unfold in a logical sequence. But a Boltzmann brain fundamentally breaks this causality. It has no causal past that leads to its current state of consciousness. Its past is contained within its instantaneous, randomly generated configuration. It doesn't remember a Big Bang because a Big Bang happened. It remembers a Big Bang because the structure of its accidental brain includes that memory. This makes it impossible to apply normal scientific reasoning, which seeks to trace back causes and effects to the very origin of its perceived reality. Distinguishing a real universe from a perfect fleeting memory of one becomes an insurmountable task for any internal observer. What observational signature, what cosmic anomaly, what statistical deviation could possibly alert a Boltzmann brain to its true nature? If its internal universe is perfectly consistent, if the laws of physics appear to hold, if cosmological models are confirmed by its perceived data, then there is no empirical handle for falsification. The only potential indicator is the statistical argument itself, that in an infinite heat-dead universe, these fleeting brains vastly outnumber sustained observers. But this is a theoretical conclusion about the ensemble of observers, not a direct empirical test applicable to any single observer's experience. This places us in a deeply solipsistic philosophical bind. Solipsism, the idea that only one's own mind is sure to exist, becomes a scientific possibility. If the Boltzmann brain hypothesis is true, then the only certainty is our fleeting internal conscious state. Everything else, the external universe, other minds, even the past, could be a convincing illusion. This is profoundly unsettling because science, at its heart, strives for objective, shareable knowledge about a reality independent of any single observer. The Boltzmann brain paradox threatens to collapse this objective quest into a subjective hallucination. Given this impenetrable empirical wall, cosmologists don't attempt to empirically falsify the Boltzmann brain hypothesis in a direct sense. Instead, they work to develop cosmological models that avoid its statistical dominance. The goal is to construct a universe where the probability of normal observers vastly outweighs that of Boltzmann brains, thus making the paradox disappear as a credible threat to our understanding. This involves theoretical maneuvers like proposing a finite lifespan for the universe, so there isn't infinite time for Boltzmann brains to emerge, or refining the measure in multiverse theories to strongly favour evolutionary paths to consciousness. These are theoretical countermeasures designed to restore coherence to cosmology, rather than direct empirical disproof of the Boltzmann brain itself. Ultimately, the Boltzmann brain paradox represents a potential hard limit on what science can definitively know about ultimate reality. It forces us to confront the humbling possibility that our most profound truths about the cosmos, painstakingly gathered over centuries, might merely be the echoes of a dead world, a fleeting, elegant dream in the eternal void. If we cannot empirically distinguish between a real, evolving universe and a perfect, self-consistent memory of one, then the very foundations of knowledge about our cosmic origins and destiny become terrifyingly fragile. This is the ultimate test of science's reach. Can it truly comprehend a reality where its own tools of verification are internal components of the very illusion it seeks to unmask? The empirical wall erected by the Boltzmann brain hypothesis leaves us in a disorienting intellectual void. If we cannot definitively prove or disprove our nature as fleeting, phantom observers, what then becomes of humanity's place in the cosmos, of our consciousness, our quest for knowledge, and our very search for meaning? This is the grand illusion, humanity's place in a recalled reality, a philosophical reckoning that strips away layers of certainty, leaving us to confront the profound implications of living in what might be the memory of a dead world. Our understanding of consciousness itself faces a radical redefinition. For millennia, we have grappled with the mystery of how a complex arrangement of matter can give rise to subjective experience, to thought, emotion, and self-awareness. The Boltzmann brain offers a terrifyingly simple, yet deeply impersonal answer. Consciousness is a statistical fluke. It is not the culmination of a vast evolutionary journey, but a random, momentary spark in the darkness. If our consciousness is merely an accidental, ephemeral configuration of particles, then our sense of agency, our belief in a unique, individuated self, becomes a part of this internal, fabricated narrative. The subjective richness of our inner world, our hopes, fears, and dreams, are no longer reflections of an active, external universe, but elements of a pre-configured memory that will dissipate as quickly as it appeared. This decenters not just humanity from the cosmic stage, but consciousness itself from any inherent purpose or design. The very fragility of reality is laid bare. We build our lives, our societies, and our sciences on the implicit assumption of a stable, objective, external world that exists independently of our perception. But if the Boltzmann brain hypothesis holds, this external reality is a grand illusion, a consistent but ultimately false memory. The objects we touch, the light we see, the voices we hear, are all components of an internally generated narrative. Our entire sensory input, our every interaction with the perceived world, becomes suspect. What does real even mean if the boundary between perception and objective truth has dissolved into a probabilistic fog? This challenges the very bedrock of our existence, making the familiar universe feel like a meticulously detailed dream from which we can never truly awaken, because there is no external reality to wake up to. For the pursuit of scientific knowledge, the implications are devastatingly profound. Centuries of observation, experimentation, and rigorous deduction, from Copernicus's heliocentrism to Einstein's relativity, from quantum mechanics to cosmological models, all rest on the faith that our methods uncover truths about an external, independent universe. But if our observations are merely elements of an internal, randomly generated memory, then all this progress is built upon sand. Our telescopes, our particle accelerators, our painstaking analyses, they are all part of the illusion, designed to generate data that perfectly confirms a fabricated reality. How can we continue to seek truth, to unravel the universe's mysteries, if the very framework of truth, the consistency of observable phenomena, is just a feature of a statistical anomaly? The scientific method, our greatest tool for understanding, becomes self-referential, forever trapped within the confines of a cosmic dream. The search for meaning, arguably humanity's most enduring quest, is plunged into an existential vacuum. If our existence is a statistical fluke in a dead universe, if our lives are mere fleeting echoes in a boundless void, then what inherent meaning or purpose can there be? The grand narratives of creation, evolution, and destiny lose their foundational support. We are not a special species on a unique planet in a vibrant cosmos. We are an accidental thought, a random spark in the eternal night. This challenges every philosophical and spiritual framework that has sought to imbue human life with significance. the universe becomes utterly indifferent, and our brief flicker of consciousness, however rich in perceived experience, is ultimately inconsequential against the backdrop of an infinite dead cosmos. Yet, humanity's resilience in the face of daunting truths has always been its defining characteristic. Would we simply succumb to this nihilistic revelation, or would we adapt? Perhaps, if confronted with such a truth, we would redefine meaning not as something externally bestowed, but as something created internally. The beauty of the illusion, the intricate complexity of our perceived universe, the profundity of our connections to one another might become even more precious, precisely because they are so fragile and ephemeral. We might embrace the dream with heightened appreciation, finding purpose in the very act of experiencing, creating, and connecting within this grand, albeit recalled, reality. The pursuit of knowledge might shift from uncovering ultimate objective truth to exploring the most consistent and beautiful aspects of our shared internal narrative. The paradox extends even to our most intimate sense of agency and free will. If our entire perceived past, including all our choices and decisions, is part of a randomly configured memory, then are our choices truly our own? Or are they simply elements of a predetermined narrative within the fluctuating brain? The illusion of choice, the feeling of making decisions, would be perfectly coherent within the brain's internal structure. Yet objectively, it would be an outcome of random chance, not a product of conscious deliberation. This dissolves the very concept of responsibility and autonomy, making us mere automatons performing a prescripted role in a cosmic play that never truly occurred. The ultimate solitude of a Boltzmann brain is a chilling thought. This is not the loneliness of an individual in a vast but populated universe, but the profound isolation of a singular consciousness in an utterly empty void. There are no other real beings to connect with, no external cosmos to share experiences with. Any perceived interactions, any loved ones, any conversations are all components of its internal fabricated world. It is a universe of one, a solitary flicker of sentience in an eternity of nothingness, a poignant echo of a social existence that never objectively took place. And what of time, the relentless current that defines our reality? The Boltzmann brain hypothesis redefines time as an internal construct, an eternity contained within a fleeting objective moment. Our billions of years of perceived cosmic history, our personal lifespans, are packed into a physical existence lasting a fraction of a second. This shatters our linear understanding of cosmic timescales, suggesting that the vastness of perceived time is merely a function of the complexity of the internal memory, not a reflection of external duration. The universe's grand narrative from Big Bang to heat death becomes a story told and concluded within a single, instantaneous thought. Despite this profound philosophical assault, the enduring wonder of the cosmos, even if it's a recalled one, remains. The perceived elegance of physical laws, the breathtaking beauty of nebulae, the intricate dance of galaxies, these are still part of our experience. The Boltzmann brain hypothesis doesn't diminish the content of this perceived reality, only its ultimate objective source. It forces us to ask whether the subjective grandeur of our universe is enough, even if it is a magnificent self-contained illusion. Our capacity for awe, for curiosity, and for the pursuit of understanding endures, even if that understanding is of a reality that exists only as a final, elegant paradox serves as a stark reminder that the universe, in its ultimate possibilities, is far more bizarre and challenging than our most grounded scientific theories might suggest. We began our intellectual odyssey by staring into the abyss of cosmic heat death, charting a universe's inevitable trajectory from fiery genesis to an ultimate, cold, and utterly featureless void. We witnessed the slow, inexorable fading of stars, the gravitational dance of black holes, and their eventual evaporation, leaving behind a cosmos so diffuse and cold that all conventional activity ceases. Yet, it was in this very desolation, this profound silence of maximal entropy, that we encountered the most unsettling whisper, the ceaseless quantum fluctuations of the vacuum, a restless sea of potential from which momentarily emerge. This led us to the truly chilling concept of the Boltzmann brain, a self-aware entity, complete with a full, coherent tapestry of memories and perceived reality, flickering into existence purely by chance in a universe that has already run its course. This is not the familiar philosophical quandary of whether our senses deceive us. It is a scientific paradox born from the very laws we use to understand reality. We contrasted this stark vision with the simulation hypothesis, finding the Boltzmann brain far more desolate and impersonal. No grand programmer orchestrates our experience. Instead, our vibrant dynamic universe is posited as a fleeting internal illusion, a spontaneous memory arising from the inert remnants of a cosmos long dead. The implications for the arrow of time are profound. A Boltzmann brain doesn't acquire memories through a causal past, but is the memory, its entire perceived history encoded in its momentary accidental configuration. This means its internal experience of linear time and evolving reality directly contradicts the external, static, heat-dead universe it temporarily inhabits. The cosmic ledger, weighing the statistical likelihood of an evolved observer like us against a randomly fluctuating Boltzmann brain, presents a truly absurd proposition. If our universe, or a larger multiverse, is truly eternal, then these phantom observers should vastly outnumber us. This statistical dominance transforms the Boltzmann brain from a mere curiosity into a profound crisis for cosmology. It challenges inflationary models, the very concept of the multiverse, and even the anthropic principle, suggesting that the most probable place for an observer to exist is not in a vibrant, evolving cosmos, but as a fleeting thought in a cosmic corpse. The illusion of order, the consistent physical laws, the grand narrative of creation itself, could all be part of this randomly assembled, self-consistent internal snapshot, not a reflection of objective, external truth. This epistemological bind, the inability to empirically distinguish, strikes at the very foundations of scientific inquiry, making our most trusted tools of verification part of the very illusion we seek to unmask. So, where does this leave humanity, poised precariously between the perceived grandeur of an evolving cosmos and the unsettling possibility of being a fleeting echo within a dead one? If our entire reality is a grand illusion, a cosmic memory, then our understanding of consciousness, our quest for knowledge, and our search for meaning are cast into a deeply unsettling light. Our consciousness, rather than being the culmination of billions of years of intricate biological and stellar evolution, becomes a statistical anomaly. Impersonal origin decenters humanity from any inherent cosmic purpose, reducing our subjective richness to a preconfigured narrative within a transient neural structure. The fragility of our perceived reality is laid bare. We operate under. But if the Boltzmann brain hypothesis is true, this external reality is a meticulous, consistent, yet ultimately false memory. Every sensory input, every touch, sight, and sound becomes part of an internally generated narrative. The very boundary between perception and objective truth dissolves, leaving us adrift in a probabilistic fog where the familiar universe becomes our entire scientific edifice, built, becomes a house of cards, our telescopes and particle accelerators, our painstaking analyses. Then can we continue to seek truth if the very framework of truth risks becoming? And what of meaning, that most human of quests, which often provide comfort and direction? Enduring capacity for wonder and resilience suggests a different path. In the face of such a terrifying truth, perhaps meaning would be redefined, fiercely, internally forged, the perceived recalled, creating a defiant meaning in the face of cosmic indifference. Profound solitude of a Boltzmann brain is not merely, it is the absolute, endlessly replayed in random ephemeral flickers. The Boltzmann brain paradox, while discomforting, is not a settled conclusion. It is a live, evolving philosophical and theoretical problem that continues to drive cosmologists to refine their models, to seek universe scenarios, phantom ones. This intellectual struggle pushes the boundaries of our understanding, forcing us to ask deeper questions about what constitutes reality, what defines consciousness, and what conditions are truly necessary for existence itself. It underscores the profound interplay between fundamental physics, statistical mechanics, and the deepest philosophical inquiries into our place in the cosmos. Regardless of whether our universe is vibrantly alive or merely a grand, fleeting memory, the intellectual journey itself is a testament to the enduring power of human curiosity. We seek to understand, to map the unknown, to challenge our assumptions, even when those challenges threaten to unravel the very fabric of our perceived reality. The Boltzmann brain paradox asks the ultimate question: are we witnesses to a living cosmos, or are we the universe's final, beautiful, and utterly random dream? The answer may forever elude empirical proof, but the asking of the question itself defines our unique position. Conscious beings striving for meaning in a cosmos that might be, in its deepest truth, an echo. We are the inheritors of a vibrant, complex reality, or perhaps the universe's most exquisite, improbable, and haunting final thought. This profound contemplation leaves us not with definitive answers, but with an enduring sense of awe for the bizarre, beautiful, and terrifying possibilities that lie at the very edge of existence and perception.